Hello my dear student, welcome to video number 142 of the channel MALACHEMPHILIC, and this video number 142 is the episode number 81 of Chemical Thermodynamics, where the topic is Thermochemistry Part-VII. Part 1 to 6 already I have finished in my earlier videos, so let's see what is there in 7th part of thermochemistry. Already I have shown you this content of thermochemistry, where from this enthalpy of reaction up to this bond enthalpy I have finished. So today I am going to discuss Hess's law. So what is Hess's law? According to Hess's law, this total heat involved in a reaction is same whether the reaction occurs directly, that means by direct path, or by indirect path, that means through a number of steps. Okay, or in other words, the heat change or enthalpy change of the reaction is independent of the path followed. Okay, so what does it mean? Let's take the example. Say the reaction is, 1 minute. Say the reaction is this conversion A to B. Okay. Here this enthalpy change is delta H1 for this direct conversion if it goes directly from A to B. Otherwise, it may go like this, from A to C, then C to D, then finally D to B. Okay. Then C, from A to C conversion, this delta H, A to C, this delta H2, that is delta H2, and C to D, this value is delta H3, and D to B, this value is delta H4. Then according to Hess's law, this delta H1, that is heat change in the direct path, will be is equal to this heat change in all this, sum of the heat change in all this indirect path, that is delta H2 plus delta H3 plus delta H4. Okay. Now, say another thing. Say this reaction is A to B. Another reaction is C to D. Right? And here the enthalpy change is delta H1, and here I am considering delta H2. Now, if you add it, then what it will be? It will be A plus C, that will give you B plus D, and here this enthalpy change will be delta H will be is equal to delta H1 plus delta H2. Okay. In other way, say same reaction A to B and C to D, if I subtract it, okay, if I subtract it, then what it will be? It will be A plus D minus minus, so it will be A plus D, minus D will come this side, and this will be is equal to B plus C. B plus C. Then this delta H will be is equal to delta H1 plus of minus delta H2. This is minus delta H2. Okay. So this is your Hess's law. That is, heat change of a reaction is independent of the path followed. Now, coming to this problem, what is given? At constant temperature, this conversion, that is allotropic form of carbon, diamond to graphite, is X kilojoules per mole. This amount of energy is released. And this combustion of diamond, that is reaction with oxygen giving carbon dioxide, here this energy released is Y kilojoule per mole, and this combustion of graphite to carbon dioxide, that is graphite reacts with oxygen give carbon dioxide, energy released is Z kilojoule per mole, and then Out of these 4 options, which one is the correct equation? Right. Now let's see. So first one, you see this combustion reaction, that is carbon diamond plus oxygen giving you carbon dioxide, and here delta H1 that is given is minus Y kilojoules per mole. Okay. Now another one is carbon graphite plus oxygen giving you carbon dioxide, and here delta H2 that is equal to minus Z kilojoules per mole. Okay. Now if you subtract it, then what we are getting? This is minus, minus, minus. Carbon dioxide getting cancelled. Oxygen getting cancelled. So this diamond minus graphite, that means the equation will be C diamond to carbon graphite. And what will be the delta H? So here delta H will be is equal to your delta H1. I have subtracted, no? Delta H1 minus delta H2. So this delta H that is equal to minus Y, then minus of minus Z. So it is minus Y plus Z. Now, as per the given equation, this carbon diamond to equation number 1, that one, diamond to carbon graphite, this value, this is also diamond to graphite, I found it out. This value, this delta H, that is equal to minus X. So, sorry, this I am taking delta H. Delta H is equal to minus X. This is X. So, this delta H minus X given, and delta H minus Y plus Z, we have found it out. So, therefore, what we can write? We can write minus X is equal to minus Y plus Z. Or we can write, what we can write? We can write X is equal to Y minus Z. X is equal to Y minus Z. So, correct option is option number D. Now, next one you see. If we are aware of standard enthalpy of formation of the reactants and product, only the enthalpy of formation of all reactants and products, then the enthalpy change of the reaction or standard enthalpy change of the reaction will be summation of total enthalpy change of the product minus summation of enthalpy change of the reactant. Okay. So here this is the reaction. Ethane reacting with oxygen giving carbon dioxide and water. So directly you can put it in the equation. What will be this delta H naught of the reaction? Okay. What are the products? Products is, okay, first I'll write, this is summation of enthalpy of the product and this is standard enthalpies. So H naught minus summation of the enthalpy of the reactant. Now we'll put the values. Okay. What are the products? Carbon dioxide. 2 moles of carbon dioxide. Carbon dioxide value is minus 90. That is 2 into minus 90. Okay. Then plus, what is the another product? Another product is water. 3 moles of water. Water value is minus 70. That means 3 into minus 70. Okay, this is my product. Now, what is the reactant? Reactant is ethane. Ethane value, how much it is given? 1 mole of ethane. Ethane value is minus 20. So, minus 20 kilocalorie. So, if I do it, this is minus 180 minus 210. Okay, and then minus minus plus plus 20. So 210, 310, 310, 390, 390 plus 20, that is 370. So it is minus 370 kilocalorie. This is the answer. So answer is option B. Now coming to the next problem. See here, when heat of combustion of all reactants and products are given, then heat of the reaction formula is summation of these enthalpies of the reactant minus summation of the enthalpy of the products, provided all the combustion value of reactants and products will be given. Okay, it should not be mixed up. One combustion, one formation, not like that. If heat of combustion formation is given, then the equation was summation of enthalpies of the product minus summation of enthalpies of the reactant, and this is the reverse one. So we'll see this one. Now find the enthalpy of formation of acetylene when delta H values of carbon, hydrogen and acetylene are given. Okay, delta H of combustion. Okay, heat of combustion, right? So my required equation is enthalpy of formation of acetylene. So required equation, that is carbon plus hydrogen, this is C2H2 acetylene, obviously it is 2. Okay. Now heat of combustion of carbon is given. So carbon plus oxygen, this is carbon dioxide. Okay. So here your delta H1, that is given as how much? This is minus 400 kilojoules, right? Now heat of combustion of hydrogen. So hydrogen plus oxygen, then it is, water delta H2, that is equal to how much it is given? Hydrogen is minus 300 kilojoules. Okay, and this heat of combustion of acetylene is given, that is C2H2 plus oxygen, then this is carbon dioxide plus water, and here it is 2 carbon, that means 2 2s are 4, 5. So it will be 5/2 oxygen, and this value delta H3, this value is minus 1300 kilojoules. Okay, now we have to find out the heat of formation of acetylene by putting in this formula, because all heat of combustion values of the reactants and products are given. So delta H reaction or Xn is equal to summation of the enthalpy of the reactant minus summation of enthalpy of the product is equal to, what is my reactant? 2 moles of carbon. Okay, carbon value is minus 400. So it is 2 into minus 400 plus another reactant is hydrogen. Hydrogen value is minus 300, only 1 mole. So it is minus 300. Okay, and then what is the Product is acetylene. What is the value of acetylene? Minus of minus 1300 kilojoules. So delta H of the reaction, that will be is equal to, so this is minus 800 minus 300 plus 1300. So it will come as 1100, 1300. So 200 kilojoules. So answer is 200 kilojoules. So answer is option A. Okay. So in my next video, I'll solve some more problems on Hess's law. So hope you have understand today's lecture. Thank you.